Okay, guys, we're going to do a little lesson on repairing a Magnafluxer. This is actually going to be a lot of electrical theory, but it'll give you a good insight on what's actually going on. Okay? Now, this is my old Magnafluxer I repaired, and when I saw that, new Magnafluxers that are $1,000, I'm like, I gotta see if I could fix this thing, because I don't have $1,000. I mean, yeah, I could ask Sophia for it, but I'd rather not take money from the kids, to buy crap from my garage. So, what I wound up doing, I was actually going to strip it and use that huge Gauss magnet I have. Let me show you that Gauss driver. That's impressive. All right. This is actually a Gauss HF4000. That's the giant Alnico magnet. To give you an idea how big it is, this hole is 2 inches in diameter. I think it's a 30 or 35 pound tweeter. Okay? This section actually is covered by an aluminum dome. Okay, that vibrates and sends it, it compresses the sound waves through this cone. And then it sends it through the throat to a giant horn. I actually had the horns for these. The horns were 30, I'm going to say 30 by 10 inch. 30 by 10, something like that. Big JBL horn. Now, Gauss is named from Carl Friedrich Gauss, who did German scientist, who did tons of magnetic experiments. Okay? Now, this is an Alnico magnet. This is super strong. In fact, it's so strong that this metal plate that transfers the magnetic field to the voice coil fits right around that edge, right by my thumbnail. That's where the voice coil would sit. It's got a 4-inch voice coil. What it does is this metal plate focuses the magnetic field around that, so it's extremely strong. These are capable of incredibly high volumes. I got these when I was maybe 20, 21 years old. I was working part-time at a recording studio on Long Island. The guy that owned it was in a band in the early 80s, Industry. Heavy metal band. Actually, it was more like an industrial metal band. But I had some interesting times working at his recording studio, and they used to use 2 of these speakers and 2 giant Altec A7 boxes. I wound up getting the A7 boxes in these. I've never rebuilt these. They've been sitting, waiting patiently for many, many years, 30 plus years. But I was going to use this magnet on my iron core to get my Magnafluxing done. And it just, as I was taking the Magnafluxer apart, I'm like, it was interesting the way it was built, right? It has the coil, and then it had literally wood around the edges, and then it was wrapped with almost a body filler. It was wrapped with body filler. I have a piece of it. Let me show you. All right, not much survived, but you can see it literally is a piece of body filler. So they wrapped the coil, they wrapped it with body filler, and then they put like a plastic. They dipped it in a plastic rubber to protect it. So what I had was, I knew I should have recorded it for you guys, but I said, that would be so boring. Well, after we go over some electrical theory, you'll find out why it's really not boring. Okay? Let's do a tiny bit of electrical theory. Okay? This is called the curl right-hand current rule. Okay? Now, on the right, we have the direction of current. So we have a conductor, and we have current going through it. Anytime you put any current through a conductor, it develops a magnetic field around it. Okay? So the right-hand rule states if your thumb is the direction of the current, your fingers wrap around, that's the way the magnetic lines of flux are going to be. Okay? And they would radiate outward. Let me draw them. Okay, as the current increases, you get more and more lines of flux going around. Okay, now take that wire and let's make 3 wires, all have the same current going through them. Those magnetic lines of flux all join together and make much stronger lines of flux, okay? So what are we doing when it comes to this? We're taking that conductor and we're wrapping it very, very tightly. It's very, very thin wire. And you wrap it very tightly so those magnetic lines of flux all add up together. And what it'll literally do is, as the current goes through, right, it makes a magnetic field like this, right? Because that would be the way those lines of flux are. Because remember, our conductors are facing this direction, right? So our lines of flux make a loop. Now take a look. I actually found a really nice heavy duty. It's actually a 3-phase switch, but it was in junk pile, so I said, you know what? I could use a good heavy duty switch for my Magnafluxer. Now, right now I've got it on top of a bunch of ground up E7 head. Take a look at what happens when I energize it to the filings. Now, it may not be that easy to see. Let's spread it out a little bit. What we did, let me draw it out. Okay, this is what we got. It turns into a magnet, right? North and south. Well, your lines of flux go from north to south. And if you take a look at how those are, you can see they can just continue to radiate out. But as they radiate out, they're going to get weaker, right? Let's move it and re-energize it, see what happens. Okay. As it goes further out, right, those lines of flux start to do this, right? All the way around, something like that. So you can see exactly what you got. Now, how do we use that to Magnaflux a cylinder head? Well, let me draw a different picture. Okay, that's what we have when it's on the cylinder head, right? The magnetic lines of flux couple through the ferrous material, right, through the iron. Now, what happens if there is a crack? Well, the magnetic lines of flux can't go through that. So what they would actually do is they would try to, right, and they can't go through. So there's going to be, it's going to change the amount of magnetic field there. That's where the magnetic dust will build up. It's actually a pretty interesting phenomenon, right? So let me explain how I wound up fixing this. I unwound the, I don't know, between 500 and 1,000 feet of wire that was on there. And I checked every inch of it. Of course, the last few feet of it was broken. So all I did is I repaired the broken wire and rewound it as tight as I possibly could. And then I insulated it. In fact, you can see the repair. The repair is here. I just used a wire nut. And I set it off to the side so it's easy to get to if it ever breaks again. You're like, a wire nut? I'm like, yeah, wire nut is just fine. In fact, wire nut is the kind of repair you want. Easy to service, right? And then I just wrapped it with some electrical tape so if it ever shorts out against the iron, it doesn't blast me. That's why it was originally, the original design was covered in a blue rubber. All right. I don't know if there's anything else I need to cover with the Magnafluxer. Great tool. If you're going to do iron heads, it's an absolute must-have. Can you make your own? I made my own out of a piece of three-phase transformer once, but it required a huge amount of current to drive it. This, you just plug it into a 120 volt outlet and energize it, and it makes a pretty strong pull. I'd say this is 35 pound pull on this. So it takes 35 pounds of effort to pull it off the cylinder head, which is plenty for what you want. You want a good, strong magnetic field. All right, guys. Thanks for hanging out. Have a good night.